Uh, Today we are going to discuss Polygon Hermez. My name is Kairav Thakkar, and we'll delve deep into the technology of Polygon Hermez, the Zk Rollups solution that it provides, and basically learn a whole lot of stuff about Ethereum Layer 1 blockchain and how rollups basically assist in making the Ethereum blockchain more scalable, more cost efficient, and allow us to process transactions on the Zk Rollup solution. So just going forward with the categories that what we are going to explore today. First, we will have a basic introduction of Polygon Hermez. Then we will dive deep into what Zk Rollups are, technically understanding what and how Zk Rollups work. Then the origin and need for Polygon Hermez. So any solution you must have a question before it. So why do we need Polygon Hermez, and why did we need basically Zk rollup solutions and even optimistic rollups in the first place, as to how they are allowing us to process transactions on the Ethereum blockchain in a better way. Then we will explore the technicalities of Hermez. We'll understand how the Polygon Hermez team has been building amazing stuff. What is the technology behind it? We'll also understand how the applications of Polygon Hermez comes into picture. In the real life applications, are there any protocols coming up into the picture? How the Polygon team is basically planning the whole ZK knowledge paradigm. They are acquiring a bunch of protocols in the zero knowledge proof space, and so understanding how these protocols will come into the picture and play a very big part into the Web3 future. Then going forward, the research and future scope of Polygon Hermez. Going forward with it, the advantages and disadvantages of Polygon Hermez, and finally, gratitude and references to the Dōjō team and relevant articles that I used to prepare for this workshop. Now let's go forward with the introduction to Polygon Hermez. So, what basically is Polygon Hermez? It's an open source ZK Rollup project. Now, when I talk about ZK, I'm talking about zero knowledge. We will learn about zero knowledge proof in the upcoming section. For now, understand that let's say you have a lot of traffic on the road and you build sort of a bridge from a point A to point B, and you try to reduce the traffic on the bridge. That's basically what rollups and sidechains do. Basically, they make a lot of transactions that are going to happen on the layer 1 blockchain. They take it, provide the validity proof for the same, and then they make these transactions more scalable, more cost efficient. These are also secure transactions happening on the layer 2 blockchain solutions. So now we have a lot of transactions happening on the layer 2 solutions, basically directed towards Ethereum, and this reduces the transfer cost significantly. Zero knowledge technology, what it does is that we, as its name suggests, we are trying to provide zero knowledge and at the same time proving it that it is valid. So how we do it, I have a very intuitive example coming up that basically puts into picture as to how zero knowledge proofs are used in the industry, and we'll move forward with it. Yeah. Now, these network basically ensure the computational integrity. So you have a Polygon Hermez Zk Rollup solution allowing for transactions to move on this layer 2, and it makes the data availability, the computational integrity available. And with the help of zero knowledge proof technology, the validity, privacy, and security of these transactions maintain the properties of the Ethereum blockchain. This project features a unique proof of donation mechanism where 40% the winning bid in block creation goes as a donation to Ethereum public goods, and the remaining 60% is basically used to incentivize the block creators. As a result of the Polygon Hermez technology, we are able to create an inclusive, resilient, and highly efficient payment network. Now, what are Zk Rollups? And basically, moving forward, what is zero knowledge technology? What are rollups? You understand. Rollups are basically layer 2 scaling solutions that process transactions off chain and periodically submit aggregate data or proof to the main blockchain. So what it does is that it takes the transactions, processes it, and then you can submit the aggregate data or proofs. So let's say you have the transaction proof, the validity proof of the transactions, that yeah, these transactions are valid, and you can then aggregate it and submit it to the main blockchain later. Now this reduces congestion on the main blockchain and it increases the transaction throughput, also reducing the gas fees that many of the Ethereum, as people who are using Ethereum might be aware, that still there's an issue about scalability and moving forward as to how we are going to reduce the gas fees on the Ethereum blockchain. Zk Rollups use zero knowledge proofs. So to understand how zero knowledge proof works, I have a very an example of let's say two balls and you have two human beings. Let's see, yeah. So here we have, let's say, a red ball and a blue ball, and this is human 1 and human 2. So let's say you have these two balls. To be you have to prove to human 2 that these two balls are of different colors without showing it to human 2. Right? Human 1 has to prove this, that this is a different color of ball and this is not the same ball. Right? So how would we do it? Right? So we would, let's say this human 2 is blindfolded and we give this red ball and blue ball to the human 2 and we tell him that you do one thing, you swap the balls, red and blue ball, behind the back and present it in front of us, right? So let's say the human 2 takes these two balls, right, and swaps the ball in his hands and presents it to human 1, right? Now the human 1 doesn't know, right, that human 2 has necessarily swapped the ball or not swapped the balls, right? It's upon human 2. But because he knows that it's red and blue, he would be able to tell that in the right hand, first it was red, now it's blue. Right? And so he would be able to tell that the balls have been swapped. Right? So human 2, on the first try, he swaps the ball. He took the red ball in the right hand, and he then swapped the balls. And now he has the blue ball in the right hand and red ball in the left hand. He shows the balls to human 1, and human 1 says, the balls have been swapped. Right? So human 2 says, oh, it's a lucky fluke. It doesn't necessarily prove that you know about it, and doesn't necessarily prove that these balls are of different color. So he swaps the ball again. Right? So now you have a red ball in right hand, a blue ball in the left hand, and again the balls have been swapped. So human 1 would be again like, now you have swapped it again. The human 2 tries again, and this time he doesn't swap the ball. Right now he has a red in the right and blue in the left. And again, he presents the ball. He said, now you haven't swapped the balls. So human 1 is accurately able to predict when human 2 has swapped the balls or not swapped the balls. Now the human 2 is thinking, how is he able to tell? The only way possible is that both the balls are of different colors, right? And that's the only way to figure out. If both the balls were red color, then there is no way that the human 1 would be able to predict that, okay, the balls have been swapped, balls have not been swapped. The only way it's possible is that both the balls are of different colors, right? And that's the only way that human 1 is able to predict that the human 2 has swapped the balls or not swapped the balls. And this proves to human 2 that both the balls are of different colors, even though human 2 hasn't seen that these two balls are of different colors. So we haven't provided the knowledge to human 2 that these balls are of different colors, but we have proven it to him. This is zero knowledge proof. And technically, it's implemented in the complex scenarios, but yeah, this is the basic crux of it. Now, Zk Rollups use these zero knowledge proofs to verify the validity of transactions privately and ensure that the computational integrity is maintained. Right? Now, we are minimizing the amount of data that is posted on chain. We are minimizing the amount of data that is posted on chain and processed on the main blockchain. And Zk Rollups basically are providing a low-cost solution and providing a sort of a bridge so that, let's say on the main road, there's less traffic. There are various number of Zk Rollup solution. By the way, when we talk about rollups, there are two types of rollups: optimistic rollups and Zk rollups. We'll talk more about it. First, let's go forward with these 4 examples of Zk rollups. So you have StackNet, which is a decentralized Zk rollup platform built on top of Ethereum blockchain, developed by the Stackware team. You have a Loop Ring, which is another Zk rollup based DEX protocol, decentralized exchange. And this is more focused towards low cost trading on Ethereum. You have Polygon Maiden, which is a Zk rollup solution based on the Zk Stack cryptographic method. Now, there are 2 types of basically Zk Stack and Zk Snack primarily, which are the rollups based on it. Polygon Hermez basically uses best of both worlds. It uses best of Zk Stack and Zk Snack world. And Polygon Maiden basically uses Zk Stack over Zk Snacks. And so you have, if we talk about Zk Snacks, these are not quantum resistant blockchain solutions. And Zk Stacks are blockchain resistant, quantum resistant blockchain solution. But on the other hand, you have Zk Snacks, elliptic cryptography, which are less complex to implement. On the other hand, Zk Stacks are more complex to implement. So you have a trade-off again, right? And Polygon Hermez brings best of both worlds. Other Zk solutions come into the picture as to how they are implementing it in their own way. But that basically depends upon how various blockchain solutions come into the picture. Let's say you have some protocols implementing Zk Stack, some protocols implementing Zk Snacks based on the requirement of the protocol. So now you have origin and need for Polygon Hermez. So it was founded by Jordi Bellina, Anthony Martin, and David Schwartz, all from Barcelona, Catalonia, basically as in Spain. And the initial idea, the vision that these team basically directed towards was decentralized identity solution during the referendum period, the independence referendum period that they were going through. And this led to the birth of Hermez Identity Project. It then evolved from the identity project to the address scalability challenges. Right? Previously, I talked about optimistic rollups. So optimistic rollups, as the name suggests, so as I was discussing, I would apologize for the technical inconvenience on my end. But as I was discussing, that you can look at the uptime of the Polygon Zk EVM. They have been pretty robust. You can look at the current status. And yeah. So even if we have these issues and the 98.75% uptime and 10.92% uptime, so I mean, pretty solid operational history. And you can look at the historical uptimes the past. So the teams are collaborating as I think they are collaborating at a much higher level, and they are shipping products into the system, and the ecosystem is robustly growing. They have released the Polygon 2.0 roadmap. Hermez uses proof of donation consensus algorithm, while Polygon Hermez 2.0 uses proof of efficiency. Now we discussed about this proof of donation and how proof of efficiency works. It's a completely open source project with extensive documentation. People can go forward and contribute towards it. Now let's look at the advantages and disadvantages of Polygon Hermez and understand how they play a huge part in the picture. So you have significant cost reduction. Because of Polygon Hermez, you have significant cost reduction in terms of how these financial services become more accessible for mainstream adoption. You have scaling solutions. That is, now you have a high throughput solution provider in terms of how the solution, the transactions are processed on the Ethereum blockchain. You have Ethereum compatibility. So all the good things about Ethereum, they come into the picture, while decreased gas fees and decreased transaction cost and increased speed come into the picture. So you have advantages, and then you have the native support of the Ethereum. And at the end of the day, as it employs proof of efficiency mechanism, it enables permissionless participation in the network. Now, these are some disadvantages of Polygon Hermez. It might present some challenges in terms of technical complexities during integration. You have Polygon Hermez, which employs zero-knowledge proof of security, and some vulnerabilities in the implementation of technology could pose risk to the network and user funds. We're talking about real millions of dollars. If you are processing, then that would be an issue. And the learning curve, the developers need to familiarize themselves, especially with zero-knowledge assembly language and ZK-friendly programming languages. A bunch of them like Kairav and stuff that are coming out, people would need to adopt and understand, especially developers who are building for the next generation. Now, let's move towards the category references. So these are the references, sort of the resources that I used for understanding about the Polygon Hermez technology, the Polygon ecosystem. Huge thanks to Thakkar Dōjō. So I showed sort of site, so people can look into the different hackathons and grants that these Thakkar Dōjō provides under DoraHacks, and you have bounties, hackathons coming into the picture, various ideas, grants which will support any ideas which people, qualified builders would have to submit the application, and you have various bounties, mini bounties, bug bounties, and DAO bounties. Various hackathons also part of the initiative. So the hacker movement is quite strong, and yeah, people should consider submitting and collaborating with the team here. I'd like to thank everyone for the workshop. You can approach me on this email ID. Also feel free to connect with me on LinkedIn and Twitter. Yeah, I think that's about it.